Hello and welcome back. We are now on episode 2 of Making a Visual Novel with Unity. Today we are going to work on building dialogue inside of our scene. And there are several methods that you could use to do this. In essence, by building dialogue, what I'm referring to is passing a string of text to a function, which then makes each character appear one at a time. This is commonly called the typewriter effect. And the most common and simplest way to do this is by adding text character by character until the final string is visible on the UI. Now that sounds great, but it's not the best way to do it, and you'll see that in a minute. But first, let's look at how it would work. It would start by sending a message with some text you want to be sent to the screen, and this text is then processed by a function or coroutine that loops through each character of text and adds it to the UI until the whole text is complete. On its own, using this with plain text seems to look fairly decent. That is, until you're building a word that's too long for the line it's currently on, and it gets snapped to the bottom of the text box. Furthermore, it gets even worse when you're trying to use tags in your text, like Text Mesh Pro or rich text tags. The tags will actually be built character by character until the system recognizes that it's a tag and basically says whoops and goes on to apply the effect. So this is not the optimal way to build text in your VN. Actually, we have a better solution, and that's one that's already been built into Unity, and it's just going to require a little bit of fancy coding on our part. Some of you may already know what I'm talking about, and that is Text Mesh Pro. Text Mesh Pro itself is an awesome text solution, and it also has a beautiful feature where it controls how many characters of text are visible at one time. And since this uses data that's compiled after tags and text positioning is in place, the end result is flawless, as we choose, instead of adding characters one at a time, to reveal them one at a time. And so that's what we're going to be doing today. So let's go ahead and get to it, and let's jump right into our scripts folder over here. And I'm going to make a subfolder and call this core. These are going to be core scripts that I place in here, and the text architect is going to be one of them. Make a new C# script and call it Text Architect. Woohoo! We got our own script. Are you proud of yourself yet? Alright, let's open that up. Great! So we now have a script for our Text Architect. Right off the bat, let's go ahead and make sure, since we're going to be working with Text Mesh Pro, we need to use their namespace. So that's just called TM Pro. Type that in, and now we can access Text Mesh Pro elements here. But let's go ahead and add 2 more scripts as well they're going to go hand in hand. So they're going to make use of the Text Architect. And that is going to just be, we're going to have one for our dialogue system, which is going to be the main controller that controls what text goes on screen and really how the text is read from files once we get that far. We're not going to do much with it right now, but we want to have at least one function in there. So let's make a dialogue system. No, I don't want you to open up yet. And as soon as that's done, let's also make a script called dialogue container. And the dialogue container is basically just going to be what we have on screen here. This little dialogue box that has the name and the dialogue text. And this is gonna pass references of these variables, and if you wanted to extend that, you could add in other references to other things on your screen specific to this dialogue container, and it'll just give us easy access to the variables, or you could assign it to different ones and even swap them out dynamically. So that's always an option there, but I'm going to stick to one right now, and we don't need it to be a mono behavior. It's not going to actually be something that's added to a game object, but it's going to be added to our dialogue system. So let's go ahead, and we're going to need TM Pro here too, using Text Mesh Pro, and we need a public game object called root, which is, we'll have both the name text and the dialogue text parented to it, so disabling the root would essentially hide the dialogue. Let's make a TMP text, and that will be for our name text, for displaying what character's talking at the time. And the next thing, we want to make another TMP text and call that dialogue text. Okay, cool. So we don't need those two right there, just Unity Engine and TM Pro. And now we can open up our dialog system. Let's go ahead and open that one up right there. Okay, so in here, how about we go ahead and make a reference to a new dialog container. So okay, great. So this creates us a dialog container. And the serialized field just makes sure that even though it's private, we can still access it from the inspector. And if we pop back into Unity, let's go ahead and make something that's going to be our dialog system, the controller for it. Root is going to be the object that's enabled and disabled to hide everything on screen, basically. So I don't want the manager to be a part of that. So I'll come into VN controller and I'll make another empty, and I'm going to call this managers and put it in brackets so that way I know it's special. All right, create empty, and this is going to be our dialog system controller. And I'll just drag that in. Ooh, but something's going on here. You notice we don't have our dialog container. It should be showing up there. So I actually already know what I did wrong, and that was I did not put the system.serializable attribute over the class. That will serialize all these variables in the class itself, so that way we can see that, you know, it's showing up in the inspector and we'll be able to assign these fields. And just like that, we have our dialog container here now. So let's go ahead and assign our elements. If we come into the dialog layer, here's our root object. So I'm going to drag that in there. Our dialog text will be there, and our name text will be there. And I'm just going to rename image to the root container. So if we were to enable or disable it, that's what the root would take care of. Okay, cool. So now that's in our dialog system. And let's go ahead and jump into the text architect and start making it where we can actually build different strings and different conversations to show on screen. So as we get ready to code this, there are different ways that you can make text appear on screen. And the goal of the text architect is to be able to do whatever you want. You can add different functions, different coroutines to build text in specific ways, and it'll still work, easily expandable. So the main ways that I know that I've seen in visual novels is you either have text that instantly shows up on screen, but then you have a typewriter style. And that one's a little better. It's a little easier on the eyes, and it makes things appear one character at a time, kind of like concatenation, but with Text Mesh Pro, we're just revealing one character at a time. So those are two methods we can use, and we will use both of them. And then there's a third method, fading in the text. And that actually has a very smooth look to it, which I happen to really like. So we'll be making all three of these, and they're actually quite simple to do. Well, with the exception of fading, that's a little more difficult, but still not very hard. So let's go ahead and take care of this. We'll remove start and update because we don't need those, and we actually don't need system.collections.generic either. We do want system.collections because we are going to use coroutines. So let's first of all, when we create a text architect, this isn't going to be a mono behavior either. We're going to instantiate it as a variable. And so the text architect is going to need something to affect. It's going to need some kind of text component. So let's make private Text Mesh Pro UGUI, which is the UI-based Text Mesh Pro, and I'll call that TM Pro UI. And I'll do the same thing for Text Mesh Pro, and that's just the world space 3D text. So if I wanted to use this for either one, I could. And then no matter which one is assigned, I want to be able to get whichever text component is assigned to this architect, whether that be UI or world space. So this one, I will make public, we call it TMP text, and this is going to be called TM Pro, just straight up TM Pro. And what this is going to do is, get out of there. This is going to say if our TM Pro UI is not equal to null. If we actually have UI space text mesh that we're working with, then we're going to use the UI space text. Otherwise, we're going to use the world space text. So no matter which one we assign to this architect, just using tmpro will let us put the text on the appropriate one. So now, as we move forward, what else is our tech architect going to need? If we're messing with text, I think we're going to want some references to the text that's being built and even the current text, just maybe a shortcut to that. So let's make a public string called current text, which will be whatever's on the text mesh pro component at this very moment. And that's just going to be equal to our tmpro.text. Next, we're going to want to get the target text. What are we trying to build? So public string target text, and we'll make this where it's publicly retrievable, but only privately assignable, and the default value will be empty. I'm going to copy that because I also want to have something called pretext. And to understand what pretext is, our text architect is going to have the ability to both create new text and also append to existing text. So pretext would be whatever is already on the architect. It's just going to be stored in this variable before the new text is tacked on top of it. In addition to that, let's also cache the pretext length, and this will come in handy later, specifically for the fade method. So just make sure you got that. Let's not worry about it too much right now. And lastly, I'm going to want the full target text. So the target text is what we're trying to either build or trying to append. And that, if it's appending, target text will be going on top of pretext. So let's get another string called full target text. And this one is going to be equal to our pretext plus our target text. And that'll give us the full string that this architect should be building. And now that we've got all that text taken care of, we also were talking about earlier the 3 different ways that you could build text, or even more if you have different things in mind. That was instant, typewriter, and fading. Well, how about we create a way to keep track of what method it is that we're using for this architect. So let's make an enumeration called build method. And the options available to us will be instant, typewriter, and fade. And by default, our build method is just going to be set to typewriter. If you also want to change the color of your text, we can do that by making ourselves a little shortcut variable called text color. Cool. Now think about how fast you want this text to be generated. What's the speed? Let's make a variable for that. Let's make a private float called base speed equals 1. Or you can make that a constant, because this will kind of be a universal speed you can tweak on your own. And then on top of that, let's make a private float called speed multiplier. And this will be something that might be able to be changed from, say, configuration menu. But the base speed is going to be universal, and you can tweak that to whatever you like. Speed multiplier will be configurable by the user. And then, to make it easy, let's go ahead and make a standard speed variable that when we get it, we're going to return the base speed multiplied by the speed multiplier. That's how fast our text will actually come in on screen. Otherwise, if we are assigning this value, since base speed can't be changed, let's just make speed multiplier equal the value that we choose to pass in. And that's how we'll configure that through the config menu. But that's available to us now, and that gives us a speed that this text architect can generate its dialog for. Now, what's another thing that visual novels usually have for their text system? It's usually like a multi-click solution where you click once and text starts appearing on screen, but if you click twice, it starts speeding up and it gets faster. and if you click a third time, then it usually just forces the completion of that text. So we'll kind of do the same thing here and make ourselves a public boolean called hurry up. And if hurry up is true, then text is just going to fade in or transition in much faster. But being on that note of changing the speed, things tend to go very fast when you speed up the text inside of a visual novel. So fast that even if we do 1 character per frame, which would be the limit of speed here, it still might not be fast enough for what you want or to match some other visual novels out there. So what we can instead do is just change the value of how many characters will appear per frame. By default, we'd be messing with 1, but say if we wanted to hurry up, we could change that to like 2 or 3, and then text would come in much faster. So let's go ahead and do that. Let's make a private int called character multiplier, and that's going to be equal to 1. And then we'll make ourselves a public integer called characters per cycle, and a cycle just being like a loop or something that makes 1 or more characters transition in or come closer to fading in. That'll be what a cycle is. So we have characters per cycle. Let's say get. If we are getting this value, then we're going to return something very particular here. We're going to base it off of what our speed is. So let me explain what this is going to be for a second. So if we get to the point where we are configuring this inside of the settings menu, and we decide to crank our text speed, the speed all the way up, then we might want to have more characters appear, similar to as if we were using hurry up. Depending on what the speed is, we might have more characters be generated at once than if it were slower. So I've calculated some values that seem to work pretty good for me in the tests, and we're just going to go ahead and type that in here. So the values that I've found work really well is if we're getting this value, we're going to return based off the speed. If it's less than or equal to 2, then we're going to return our character multiplier, just the default value. So speed's any less than 2, we're just running off default. Otherwise, if speed is less than or equal to 2.5, then we're going to return our character multiplier times 2. So we'll move up to 2 characters per second. Otherwise, we're going to do character multiplier times 3. And so that way, as we speed up the how fast the text comes in on screen, we can really make it fast, and we can make it slow if we wanted to. But that's basically it for the variables that we're going to work with right now. That's kind of the configuration limit for the text architect right now. So let's go ahead and actually start making the code here to start bringing things in screen. So let's go ahead and start coding the very core of this class here. And since this text architect isn't going to be assigned to any game object, but it's going to be instantiated as a variable, we want to make sure that it has a constructor. That way we can pass in either a UI text or a world text and have it configure itself appropriately. So let's go ahead and make a constructor for the text architect. And the first one we're going to do is I'm going to say text mesh pro UGUI, call it tmpro UI. And if we pass in UI text, then we're going to say this dot tmpro UI equals tmpro UI. And we'll copy that and just do the same thing for if we wanted to add in world text. So text mesh pro tmpro world, say this dot tmpro world equals tmpro world. There we go. So with that, we can either assign UI or 3D space text to our architect. And now for the logic of this, like I said, we're going to have 2 different ways that it can bring in text, and that's going to be either by making a completely new string or by adding on to what it already has. So these 2 methods are going to be called building and appending. And so what I want to do is I want to make a coroutine for both of these. That way, if I have a system that is waiting on this architect to finish, we can have a reference to the coroutine that's building the text and simply delay whatever actions we want until the text architect says that it's completed. So let's make a function that returns a coroutine value called build. And inside of this, let's give it a variable for the text. And if we're building, we want to make sure that our pretext is empty because we're not adding anything to it. And our target text is going to equal whatever text it is that we just passed in. Okay, now another thing, if we were to call this while it's already building text, we would want to stop that process. So let's make a way to monitor that and figure out if the text architect is already building something and put an end to it if it is. We'll just do something very simple and make a reference to a coroutine, and this will be called the build process. By default, it's going to be null. There won't be anything assigned to it, but the build process is what's going to be handling the text generation. And now let's make a public boolean or bool called isBuilding, and that will return true if our build process is not equal to null. And now to make things pretty friendly for us, let's make a function to actually stop a coroutine if it's running. Let's say public void stop, and if we are not building currently, then let's just return and do nothing. But if we are, then we need to stop the coroutine. Now, another note, since our text architect is not a monobehavior, it can't actually run a coroutine itself. But what is a monobehavior is the TextMesh Pro object that we'll have assigned to it. So we can reference that and stop the coroutine build process that's running on that TextMesh Pro object. And we'll do that, of course, by saying tmpro in reference to that text, and say stop coroutine, followed by the build process. Build process is not actually assigned yet, but it will be here very shortly. So we're going to stop the process if it's running, and then we will just set it to null. That way it doesn't think it's still running. And so in our build method, after we clear out the text, let's go ahead and make sure that there's no active build process running right now. And after we verified there's nothing running, we want to start our own build process. So the way we'll do that is we need something to actually start. And this is going to be an IEnumerator, which we will call, we'll just call this building. And we're going to call it building, if I can type correctly. All right, so there's our little thing, and just to make it happy, let's just yield return null there, because you can't have an IEnumerator and it not yield. So now let's go ahead and make sure that we have build process. We're going to assign to that variable this coroutine that we're about to start. So we'll reference our tmpro object again, and we'll say start coroutine, and then we're going to tell it to start that building process. So that's going to store the process. It'll now be running, and since we're returning a coroutine here, if we want something to monitor that, we can either reference the build process externally via that script, or we can just take the return type of this command. So we'll go ahead and return the build process. And that's the basic layout for our build coroutine. Now let's do the same thing for append, and it's basically the same, so we'll copy that, change this to append, only pretext is now going to equal tmpro.text. And target text will still equal text, will still stop, and we'll still build the coroutine and return the process. Cool. So now let's go ahead and build it. And I should say real quick, you're not seeing me put a lot of comments in here, but it probably would be wise for you to comment your stuff, like, in Visual Studio you can do triple / and then make a summary and then say what this is all about, like append text to what is already in the text architect. Because, you know, when you come back to this years later, or who knows what, if you don't have comments and your stuff isn't well labeled, then you are not going to know what is what. And that is a common warning for all coders. But enough of that. Let's go ahead and jump into our building coroutine here. Since we have 3 different methods here for building stuff, the way that they're going to initialize and the way they're going to run is going to be much different from each other. Such as typewriter, all it's going to do is change what characters are visible from the start. It's going to say nothing's visible, or only the pretext is visible, and then we're going to reveal one character at a time. Whereas fade, everything is technically visible, but we're going to be affecting the alpha values. So the initialization is very different. So as we start this building process, it would be wise for us to have probably a private void called prepare, which is going to prepare us based on whichever build method we have, so that way our TextMesh Pro object is ready to build the text and we don't have any glitches. So we'll say prepare right there at the start, just like that. And now, depending on what our build process is, let's run a switch and pass in our build method. I was calling it build process. I meant build method. But for instant, it's just going to automatically apply the text, so we don't need to worry about building anything there. We'll handle that in prepare. But for typewriter and fade and anything else you might add, we'll want to make a case and say build method dot instant. No, not instant. Typewriter. That would be our first one. We're going to do something with that once we make a little more logic here. Let's make another case for fade. So what would we do if we found out that we were using typewriter or fade? Well, since it's still a build process, we could just yield for another coroutine here. So that's actually what we're going to do. Let's make a private IEnumerator called build underscore typewriter. And I'll make another one for fade as well. Call it build underscore fade. Fade is going to be in the next episode, because that'll be, frankly, pretty long. I don't want to go too long with this. But as we go back in here, we'll say yield, return, and we can just call build typewriter. So we're going to yield for however long that duration is. And we'll do the same for fade. Build fade. Okay, so we've prepared, and at this point, after we apply the logic, we've built the text. So then we'll want to run something once it's completed. So let's give ourselves one more function here. Private void on complete. This is just going to be some basic logic that runs once the build process is done. And inside of onComplete, we can just go ahead and make sure that our build process is removed, so that way it doesn't think that it's still trying to build anything. But now let's look at our preparation, how we're going to prepare these things. Let's start very simple. Let's start with instant, and we'll actually hop into Unity after we take care of this so we can see it in action. So let's make, just like we have a different coroutine for building typewriter and building fade, let's have a different coroutine for preparing each method as well. I'm going to say private void prepare underscore instant, and just duplicate that for typewriter and fade. Awesome, there we go. Okay, there we go. So we've got instant typewriter and fade ready for us to work with. But in order for us to get here, we have to run another switch in our preparation method. So we'll say switch build method, the variable, not the data type, then case instant, like one for typewriter and fade, and then inside of here we'll say prepare instant, prepare typewriter, and prepare fade. Instant's going to be very simple. But once again, to the effect of fade, we said we were going to be changing colors to work with that because we're going to be changing the alpha value of the characters. So we want to make sure that if we just so happen to be toggling between different display methods with this text architect, that we don't let having set the color in one method earlier affect our other text not showing at all. So the first thing we'll do is we'll reset the color. The color is going to be set to tmpro .color, which basically just forces it to reinitialize itself. Yes, it's the same value, but the colors that we're changing in fade is not the actual color on the text object itself, it's the color on the vertices. So if we reapply the color to the whole object, it's going to reapply it to all the vertices. So that's what that is. And the next thing we want to do is we want to just go ahead and set the text directly to what we're trying to build. So tmpro.text equals full target text, which is our pre-text plus our target text. And then here's the method that you really need to use if you want to use Text Mesh Pro and update its mesh and its characters and all that good stuff. There's a particular function called tmpro.force mesh update. So any changes we make is going to be applied at this point. If we change the characters, it's going to be applied. And after we take care of that, we want to make sure that we set another variable of tmpro, which is what we'll be using in typewriter, called max visible characters. And we'll set that equal to tmpro.textinfo.character count. And textinfo is what's going to be regenerated when we force the mesh update. So what we're saying is reset your color, make sure you're fully visible, make sure you've got the text that you're trying to assign, force it to update, and then make sure every character is visible on screen. And as I step into Unity here, if I open my console, you see we've got an error. That's what I was talking about. Our coroutines need to return something. So typewriter, I thought we did. No, apparently not. That was a different one. Okay, so we'll just for now say yield return null and yield return null. Where's my autocomplete on that one, huh? There we go. So our text is actually ready to use that instant method here. So what do you say we go ahead and make a test script that allows us to just test that? Let's hop into our testing folder, and I'm going to create a folder inside of here called scripts. And inside of here, let's make a new script called testing architect. And let's open that bad boy up. First thing I want to do is I want to isolate any testing scripts from the rest of my project, so I'll make a separate namespace for it called testing. And a namespace is just like Unity Engine up here, system.collections. It holds its own classes, text, variables, a lot of different things, and if you are using the namespace, then you can access all of that stuff. But if you're not using it, then you won't even see it in like your IntelliSense and autocompletes. So this kind of isolates it in a way. That way I don't have to look at all my testing scripts when I'm just working in regular files. But this script is going to need access to a couple things. Let's step back in here. We're going to need access to our dialog text for one thing. And what has that is our dialog system controller. So we are going to need to access that. Let's go ahead and go back into the dialog system, and so to make sure our other scripts have an easy way to access the dialog system, we know there's only going to be one in the scene, because it's going to be controlling all of it. So we can make ourselves a singleton. Boy, I hate it when my enter key does that. Alright, to make the singleton, let's go ahead and define a public static reference to itself. Call that instance, and then inside of awake, we're going to say instance equals this. So we're basically going to make it so there can only be one of these in the scene at a time. So we're going to say if instance equals null, if there is no other dialog system, instance equals this. Otherwise, destroy immediate game object. Remove it from the scene. There we go. That's just how you make sure that there's only one singleton in the scene, just a little precaution, if you will. But now that we've got that, guess what our testing architect can do? We can now gain access to the dialog system, I'll call it DS, and say that DS equals dialog system.instance. And since start is called after awake, it'll be able to find it. Which means we will then have access to the dialog container as well. So ds dot if I were actually to make that public, which it's not, so let's actually just get a reference to the fields inside of it. I'm going to use tmpro and say public. I'm going to make it where I can access the text from this object. You know, I think it would just be simpler if I made this thing accessible from the outside, especially if I'm going to be swapping it out, potentially. We'll just call that public. So then we could say ds.dialog container, and then we've got access to the text in here. What I want to do is I want to create a text architect. So we'll say text architect equals new text architect, and here's where we pass in the text field. So I'm not going to define it there, I'm going to define it in start, where architect equals new text architect, and pass in ds.dialogcontainer.dialog text. So that way that's the text that it's going to be affecting. But it's red because you know what I did? I went and I made this TMP text instead of TextMesh Pro UGUI, which would just make more sense because it is UI based text. We're not actually changing that out. There we go. So now we have an architect that's fully working. So let's go ahead and set up a control here. So if input get, good lord. All right, so if input get key down, key code space. If I press the space key, what I want to do is I want to make the architect say something. But let me first give myself something to say. There we go. So now I've got some different lines I can choose from. So if I press the space key, what I want to do is I want to say architect.build, and I'm going to pass in one of these lines, just a random one. So it'll build just one of those random lines. So now let me go ahead and give something to test here. I'm going to make a new empty object, but I don't want that to be part of my VN controller. I want that to be outside, and I want to make this clearly a testing object. Alright, so now I'm going to make a sub item and call this text architect testing. Can you tell I might be a little OCD with my organization here? Let's hop into testing scripts and just drag that script on there. Cool, so now it's going to run. And now would be a really good time to save my scene and save yours too. And let's go ahead and see if that script runs all right. So interestingly, as I hit my space key, I'm getting absolutely nothing. And that's because I'm a genius. My build method is defaulting to typewriter, but we only have instance set up. So inside of testing, after I create the architect, I'm also going to set the architect dot build method to equal instant. And now as I'm back in Unity, as I hit the spacebar, you can see that the text changes to one of those random lines. There we go. So yeah, instant, super easy. Let's do typewriter. So first things first, we need to prepare it, just like we did for instant. But whereas instant completed itself, typewriter is just going to get ready. So here's what we want to do. We want to do the same thing that we did earlier by setting the color. And we're going to start off by doing the same thing, saying tmpro.color equals tmpro.color. That way if we were fading, then we're just going to make sure our color's right. And this time, we're going to start off typewriter by saying tmpro.max visible characters equals 0. We don't want anything to be visible at the moment. And let's go ahead and assign tmpro.text to equal whatever our pretext may be. If it's empty, then it's just going to be nothing. But let's check that. If pretext is not equal to nothing, then we want to do something. What do we want to do? We want to say tmpro.forceMeshUpdate. That way we can get the text, the pretext up. And then we want to say tmpro.maxVisibleCharacters equals tmpro.the newly generated text info.character count, the length of our pretext. And then, regardless of if we had a pretext or not, we'll go ahead and set the text to be plus equal to our target text. And then, once more, tmpro.forceMeshUpdate. So basically, again, what this is doing is it's resetting itself to make sure we're in good starting order, and then it's checking if we have pretext, forcing itself to update, and then making sure that all of the pretext is visible, and then we go on to add the target, and now it's time to build. And building for typewriter is pretty simple, just like instant. Just a couple lines we're going to have to do here. So let's come down here and let's get rid of that yield return there that made the coroutine so happy, and let's add ourselves a while loop. While what? We want to make sure that we are getting our max visible characters to the maximum character count. So while tmpro.maxVisibleCharacters is less than tmpro.textinfo.characterCount, while we still have characters that need to become visible, then let's go ahead and increase that amount. Max visible characters plus equals a certain amount. And we'll say characters per cycle, because that's the amount of characters that we want to come in per frame. But wait, we also had some other variables that messed with this, didn't we? Such as our hurry up. If we're hurrying up, then we want the build process to be much faster. So let's take that into account and say, if we are hurrying up, then we're not just going to use the characters per cycle, but we're going to use the characters per cycle multiplied by a large amount to make it go very fast. And I'll set this to 5. But we don't just want to run this every frame, we want to yield this for a certain amount of time, that way we can actually see it being built and it's not just, like, hey, here it is, almost like instant. So let's yield for a time. We'll say yield return new wait for seconds, and a value that I found to be pretty good is about 0.015, divided by whatever our speed might be. And that's it. That's typewriter for you. The only thing we don't have is our fade, but that's okay. We'll do that in the next episode. And let's go ahead and hop back into our testing and make sure that instead of instant, now we're using typewriter. And here we go. Here's the test. We're in the Unity scene, and if I hit the spacebar, there we go. It's now building the dialogue. Awesome. But that's just building. We've also got a pending that we can do. But that's already set up. All we need to do is go into our testing script and actually use it. So let's go ahead and do that. So if I do the spacebar, I'm going to make a new line. But if instead, if I press the A key, then I want to append a line. And I'm going to do the same thing here, but I'm just going to say append instead. And here we go, moment of truth. Go to the spacebar and A key. There we go. We have text appending. Nice. Ain't that nice? All right, cool. But what about our hurry up feature? What if we were to go ahead and double click or triple click here? I mean, what would that do for us right now? Well, currently we just set it to stop whatever build process is running and then restart a new one. So this is all we would get if we're just tapping that thing like a trigger. So let's go ahead and make sure that we have something set up in this testing just to simulate that multi-click and that hurry up sequence. Let's go in here, and I want to say if I'm pressing the space bar, then if my architect dot is building, so if the architect is building something, I don't know why I keep repeating obvious things, but hopefully y'all don't get annoyed with that. So if it is building, then what it's going to do is it's going to check if the architect dot hurry up is true. Actually, if it's not true, then architect dot hurry up. Okay, equals true. Okay, so if it's not building, then we're going to start building something. If it is building and it's not hurrying up, it's going to hurry up. But if I've triple clicked it, then I want it to force complete. But we don't have a method for that yet. So let's go back into our text architect and make that. Back in here, let's go ahead and scroll down. Well, where's our onComplete method? I'll put it right here. We'll make this a public void called forceComplete. And what this is going to do is it's going to check whatever our build method is and do something specific for it. Okay, so if we're using typewriter, then we want to mess with those max visible characters. tmpro.max visible characters equals tmpro.textinfo.character count. There we go, that's it. Only once we're done with force complete, let's go ahead and say stop and on complete. And on complete, since we're now messing with our hurry up, if we complete a line, then it no longer needs to rush, so we can say hurry up equals false in on complete. And so now, if we're building and it's already hurrying up and we press it again, let's say architect.forceComplete. So a single click will bring in a new line, double click should make it go faster, and third click should make it complete no matter where it is. So with that in mind, this is going pretty fast. There's not much dialogue here. I'm gonna just make a new line temporarily. Say string long line equals something long. This is a very long line that makes no sense, but I am just populating it with stuff because, you know, stuff is good, right? I like stuff. You like stuff. We all like stuff. And the turkey gets stuffed. Alright, there we go. So that's our long line. And so instead of building a random one, I'm going to comment that out real quick. And I'm going to make a new line, which will append the long line. And for this one, it's going to build the long line. Okay, let's try that out. Single click brings it up, double click makes it go fast, and triple click finishes it. Perfect. And if we wanted to do anything like, say, architect.speed equals 0.5, we can slow it down halfway. And then it makes our text appear slower. So there you go. That's our text architect so far. The only thing we've got to do left is make the fade functions, but I'll throw that in an optional video, and that'll be the next one right after this one. But there we go. We've now got a system that will allow us to put dialogue on our screen. Hope you feel good with yourself. Give yourself a pat on the back if you followed all the way through. That is, it's not exactly beginner code, I would say, which is why I said this is not really for beginners, but I hope I'm going slow enough for those who are beginners that it's easy enough to follow me, but not too slow that for all you experienced folks out there, you're like, get a move on, dude. But yeah, so next episode, it's going to be an optional episode. We're going to be finishing off the architect, making that fade function so we can have text smoothly come in on screen. And then the episode after that, next week, that's going to be where we're going to start actually using some dialog files. And we're going to load lines, we're going to get speaker names, and we're going to get text showing up from a file. All right, look forward to that. I hope you guys have a great week, and I'll see you in the next video.